So the topic we are going to discuss is heavy metal contamination in soil, water, fodder, paddy, and some of the popular vegetable crops due to the irrigation with polluted Musi River in and around Hyderabad city in Telangana state of India. So this is the map of showing the Telangana state. So the Telangana state was formed after the bifurcation of the combined Andhra Pradesh. So this is the 29th state in the India. So this is the location, that is the area, study area of the Telangana state. It is showing. So this area we can see the river crossing this Nalgonda and inland and around Hyderabad city. So this is the map of the Telangana state. So this is the study area. Just now I told you. So these three districts. This is Hyderabad and Rangareddy districts and some part of the Nalgonda districts. Where in Hyderabad and Rangareddy districts, in and around this urban area, the vegetables and paragraphs is grown, and whereas in Nalgonda district area, the paddy crop is grown. So as you know, this is the aerial map of the city showing the buildings and as well as the river. So you can see the aerial view of the Telangana state. It is the 29th state in India. And coming to this, this is already I was seen the location. Uh, So Hyderabad, it is the capital city of the state of Telangana. It has 172 square kilometers area and population of 3.6 million population, and small river that is by name the Musi. It passes through the city and enters into the adjoining districts in addition to the urban area of the Hyderabad and Rangareddy districts. Water in this area traditionally was once upon it was good along the banks in the areas which have now become peri-urban region in the capital city. So over the years, the crops like fodder, grasses, vegetables, and paddy crop were being grown using this water on the banks. Then as and when this area has become urbanization, the sewage water of the city and wastewater from the industries established around the city is let into the Musi River. Consequently, these mixed water started entering into the farmers' fields. So recently, it has brought to the notice that the crops being raised with this water used from this river is not performing well. So showing the symptoms such as yellowing of the leafy vegetables, reddening of the leaves in the some of the selected patches where the different types of crops are grown. So therefore, it is decided and a survey was initiated by the university, that is erstwhile Acharya Engineering Agriculture University. Now it is Professor Jayashankar Telangana State Agriculture University. So the survey was initiated during that time in such selected spots of for soil, water, and plant samples to assess the level of the pollution in these components. So around, by 520 locations were sampled at random within these hotspots over the continuously 3 years. Only heavy metal status of these studies is reported here. Of course, we have analyzed some other elements and soil and irrigation water status also. But in this study, we are projecting the heavy metal status. So the emphasis was also laid out regarding the entry of the metal pollutants in the milch animals, which are the part of the livelihood in this area, as they use the fodder grasses grown in that area for their animals. So this is the view of the, Musi. This is the view of the Musi River area, and you can see this the aerial view of the Musi River and adjoining areas under cultivation along with the city buildings. So this is the synaptic view of showing the part of the Musi River passing through the city. You can have a look at this water flowing in this Musi River. The quality of this water is affected with the mixing of the industrial effluents and domestic sewage. Though this was a river, this often appears to be as a drain due to the contaminants letting into this river. So this is the when we have, as I said, we collected the samples, water samples, soil samples, and plant samples at the selected locations. So this data you can see that the analysis of the water projected here. You can easily this you can see. The water samples collected here are slightly acidic to neutral in reaction, that is pH ranges from 6.3 to 7.5, and water is saline, that is electrical conductivity ranging from 2.58 to 4.07 decisiemens per meter. So this pollution is mainly due to here you can see the different heavy metals analyzed. So these are the heavy metals analyzed. These are the mean content permissible limits. Actually, the cadmium supposed to be 0.005 and chromium supposed to be 0.05 and nickel supposed to be zero point zero 0.05 and lead supposed to be 0.05, cobalt supposed to be 0.005. All these are the ppm units. So when we see the mean contents which we recorded in the water samples collected along the Musi River, so you can see this cadmium, mainly this cadmium, nickel, lead, cobalt were excess in the quantities in the water when compared to the permissible limits. So 100%, all the samples collected, water samples collected were having excess amounts of the cobalt, and 90% of the samples were having the excess amount of the cadmium and nickel, and 85% of the total samples collected were having excess amount of the nickel. So the cadmium, nickel, lead, and cobalt are the prominent heavy metals which are having in excess quantities in water when compared to the permissible limit supposed to be. So this pollution is mainly due to the mix of industrial effluent with urban sewage water which flows into the river. This is the graphical representation of showing the heavy metal contents, the percentage of the samples which were having the excess amounts of these elements, mainly cobalt, lead, cadmium, and nickel. Then, when this water we are irrigating to the soil, where these soils are used for cultivation of the different crops. So when we see the analysis of these soils, you can see the all soils are sandy loam in texture, acidic to neutral in reaction, that is 5.05 to 7.58 pH, and saline. All the soils are saline in the nature, EC ranging from 1.0 to 6.13 decisiemens per meter. So you can see here these are the permissible limits which are supposed to be. So the soil should not have more than these permissible limits. Then it will be called toxic. So if you see the mean content of these heavy metals, you see the cadmium is mean content is 0.37, and the chromium is the 1.32 mean quantity, nickel 2.79 ppm, lead 12.58 ppm. So when we compare with the permissible limits, these all are in excess quantities, these four elements. So the 32% of the total samples collected were having more amounts, excess amounts of the lead, followed by the 22% of the samples were having excess amount of nickel, and 10% of the soil samples were having excess amount of the cadmium. So these soils, because these are irrigated with the polluted Musi river water, which are contaminated with heavy metals, are causing the increasing the heavy metal content in the soils also, when over the years this polluted river, I mean river water is being used for raising the crops on the soils. This is the Musi river irrigating the, fodder crops. You can see the how this Musi river is flowing and fodder crop how it is, affected. Then, because in and around Hyderabad and Rangareddy districts, what the farmers will do, they will raise the paragrass crop because which they can supply to the milch animals in and around these city areas. So the farmers are growing paragraph, cultivating with this polluted irrigation water. So this is the analysis of the paragraphs which are showing the different heavy metal contaminant contents in the paragraphs. So we can see the Musi River water analysis. We have already the analysis is seen. Then, so this is the paragraphs. Okay, this is the accumulation of the heavy metals in the paragraphs. So here, all these samples were found to be excess in lead as compared to its permissible limits, except cobalt. 4 to 60% of samples showed excess amounts of different heavy metals and micronutrients. The paragraphs with such excess amounts of heavy metals in some locations is being fed to milch and draught animals in these selected spots. So therefore, these studies continue to see the level of accumulation of these metals in the milch animals that are raised by using these gases. So all this you can see these heavy metals, paragraphs having excess amounts of heavy metals in some of the pockets in and around city. This is the general view of this irrigated with the Musi River. The general view of the paragraphs of the spinach, paragraphs. This is the aerial view how it is being affected. So this is a small patch of the paragraph being raised with Musi river water during summer. It is mainly such patches are often raised. In the river bed itself, as water flow becomes nominal in the center of the river bed. So the milk samples collected from the buffaloes that have been fed with this type of grass are analyzed, and data is presented in subsequent tables. So this here you can see uh, the data of the heavy metals collected, in the milk samples of the buffaloes with the help of the veterinary department, state government. We have selected some of the buffaloes which were fed with this, affected pollutant heavy metals affected paragraphs. So milk samples were collected from those milk animals, and this is you can see the data. So these are the permissible limits supposed to be. Cadmium is supposed to be in milk samples 0.005. It is the safe limit. So beyond this, it is not safe. Like that, cadmium should be zero point zero 0.05 ppm, and nickel should be zero point zero 0.05 ppm, and lead should be zero point zero 0.05 ppm. But if you see the mean contents of the these cadmium, chromium, and nickel lead in the milk samples, all samples are having the excess amounts of the quantities of the cadmium, chromium, nickel, lead when compared to the permissible limits which are supposed to be. So all the samples, 100%, all the samples were collected were having excess amounts of the heavy metals that like cadmium, chromium, and nickel and lead. So these heavy loads of heavy metals in edible food products should be the main concern while suggesting the remedial measures to overcome the metal entry into food chain, because our people in and around city this milk supply will be done. So they are consuming this milk. So invariably, these all these quantities of heavy metals are going into the chain of the human beings, which is the main concern. Then we have also collected samples for, urine and serum samples also from the milk animals. So this it has been observed that these milk, in addition to these milk samples, the heavy metal contents were also recorded in urine and serum samples of the buffalo, which were found to be high in varying in nature. The intake of the unacceptable levels of the heavy metals is most likely to impair the healthy of the health of the animals. Then this is the again general view of the farmers' fields using the Musi River water. We have taken photograph here. Here, what we can observe this the crops raised with the Musi River water during the monsoon period, or whatever water in their fields, it will be less. So So this is the paddy crop analysis. I have already told in and around Hyderabad city the paragraphs and vegetables are grown, but where in adjacent district of Nalgonda the mainly paddy crop is grown. So we have taken samples from the paddy, that grass as well as the paddy plant samples. We have analyzed for the heavy metals. So we compared the crops grown in the normal soil and crops grown in the polluted soils. How this variation of the heavy metals are there due to the irrigation of the polluted water. Here you can clearly see that these are the contents in the normal soil and these are the contents in the polluted soil. If you see the cadmium content in the normal soil is 0.06 ppm, whereas in polluted soils is zero point 0.8 ppm. You can see the 13 times more of the cadmium content in the crop grown, that is straw content grown in paddy straw content grown on the polluted soils. Similarly, the lead content in the paddy straw grown on the normal soil is 0.24 ppm, whereas the paddy straw content grown on the polluted soil is 20.07. You can see the 83 times more than the normal soil. Similarly, nickel, the normal soil, the content in the paddy straw was 0.021 ppm, whereas in the polluted soil 4.07 ppm. So 19 times more in the in respect to the nickel content in the paddy straw grown on the polluted soil when compared to the normal soil. Similarly, similar trend was observed with the chromium also. 16 times was more in the quantities when compared to the paddy straw grown on the normal soils. So use of such paddy straw as animal fodder over the time can be fatal to the milk and draught animals. This is the again different paddy crop varieties grown in Nalgonda district with the Musi River water. So we have number of high yielding rice crops like Samba Mashuri, Jagityala Sanalu, Nandala Sanalu. These are the fine grain varieties. Generally, the farmers will prefer because it fetches the high price and fine cooking quality. So you can see this crop how it is looking. Among these, Samba Mashuri, the ruling variety, and Nandala, these are the different varieties grown. And you can see the healthy look. What happened? The crop, if you see this crop, it is looking very nice, healthy looking. Healthy look like paddy crop is raised with the polluted water. Why? Because this polluted water is containing high amounts of the nitrogen. So that's why the crop looks to be very healthy, lusty green appearance looks to be very good when we use this polluted water. But the main concern is the after effect, that is the quality of the grain and the quantity of the grain. The grain at the final stage will be we find the coffee grains, and the cooking quality of the grain is also very poor. This, then this is the stage at the harvesting stage. We can see this all when it is effluent water, it is irrigated crop at harvest stage with all chaffy grains looking, and poor filling of the grain we can see here. Then coming to leafy vegetables, as I already told, in and around city, with this polluted water, the farmers are taking up different types of vegetables in addition to the paragraphs. Paragraphs, of course, they are raising and supplying to the farmers with for the consumption by the milk animals like buffaloes, which supplies milk to the consumers. But in addition to that, they are also growing with this water with different types of vegetables, includes leafy vegetables, normal vegetables, and tuber crops also. These are the leafy vegetables like pollock, amaranthus, and chukagora. This is rumex species. These different types of leafy vegetables they are the farmers are taking up. So you see the heavy metal contents, how these are more in quantity, I mean contents, this cadmium, lead, nickel, chromium and cobalt. So Pollock, Amaranthus, Chikagura. Among this, you can see the mainly the more contents are observed in the Sumac species, Chukakura species, I mean followed by the Pollock and Amaranthus. So mainly in the city or people population they are consuming more pollock and amaranthus leafy vegetables. So there is a possibility of entry of these heavy metals into the human chain. So consumption of such crop produce can be health damaging in the short run and fatal over the long periods if such practice is followed. You see this Chukakura is having more amount of heavy metals followed by the pollock and amaranthus. Then other vegetables like clustered bean, brinjal, bendi, these are the mainly consumpted vegetables. Here also you can see the because this heavy metal contents in these different types of vegetables, it differs species to species. So one vegetable will be having less quantities, other vegetable will be having more quantities. Like that we have compared. Here also the bendi vegetable crop was having more amounts of the heavy metals followed by the clustered bean and brinjal. So you can see the here, see the main content of the which is causing of concern is the lead. So this is the lead quantity. 21 is the ppm mean lead content is observed, followed by the 17.37 ppm of the chromium and 3.99 ppm cobalt and 1.6962 pm cadmium. So these are the heavy metals in the normal vegetables like custard bean, brinjal, and bendi. Then coming to the, I mean, tuber crops also our people will consume like carrot, colocasia. So these tuber crops are also main concerned with the heavy metals. If you see the when compared to the carrot and colocasia, carrot crop is having more amounts of heavy metals when compared to the colocasia. As I told you, the heavy metal content differs from species to species. So this is the more this is normal the average contents of the heavy metals. So the chromium is the more content is observed in the different tuber crops, that is 37.6 ppm, followed by the lead 20.01 ppm and cadmium 2.47 ppm and lastly 1.65 ppm cobalt. So then we compared the different metal load when leafy vegetables, what much the quantities will be there, and normal vegetables like brinjal, bendi, and tuber crops. When compared these crops, the heavy metal contents in the different types of crops irrigated with the Musi River polluted water, the maximum content of the heavy metals were observed in the leafy vegetables because directly these leafy vegetables are the edible parts we are going to consume. So this is the main concern for the human beings. So leafy vegetables will be having more amounts of the heavy metals, followed by the tuber crops, and finally the vegetable crops. So leafy vegetables, when consumed, we have to take more precautions with respect to the heavy metals. So these are the different metals we have already shown in different form. The figures in the parentheses are the, how many number of times more than the permissible limits. We see we are mainly concerned about the cadmium. We see the cadmium, for example, chromium. We can see the 25 times of chromium is more in leafy vegetables, 21 times more in normal vegetables, and 25 times more in the tuber crops. Overall, in vegetables, 23 times or more of the chromium content observed when compared to the reference limit, which are supposed to be safe limit, supposed to be. So 23 times are more, and lead was and cobalt also 43 times were more, and lead was also 15 times more. So this is the main concern when we consume the vegetables here. This is and again what we have done in the in and around city, the vegetables are supplying, the farmers are supplying to the different Raitu Bazaars, that is market committees, market bazaars. Mainly in the city, there are the main Raitu Bazaars, Mehripatnam and Sanat Nagar and Monda. So we have collected different vegetable samples in different markets and analyzed it for the heavy metal contents. We compared with the, market to market because the suppliers also varies from market to market. They will supply to the nearest market. If you see the market-wise, this one heavy metal load, 778.93 ppm was recorded in Mehdipatnam market and followed by the Monda market 698 ppm and Sanat Nagar market 620 ppm. Among all these, the main concern was about lead. This is the lead. In all the markets, you can see all the markets is mainly the lead followed by the chromium. Then again, we have collected samples. So we compared to season because what happens in season to season, the rainy season, suppose a lot of rainfall will be there, so the Musi river water will be diluted with the rainwater. So naturally, the heavy metal contents will be less. When we irrigate with that rainy water, diluted water, contamination may be less. As compared to summer season, the water is evaporated from the river, and the concentration of the heavy metals will be more in the water. So if we irrigate that type of water to the crops, this is more harmful nature. So winter region, it will be somewhat average. When compared to it will not be more or it will not be so less. So, average. If you see this different heavy metal, you see all the heavy metals, that is cadmium, chromium, nickel, and lead, are comparatively low in quantities in the samples collected in the rainy season, and they will be very high in in the samples collected during the summer season. And winter season, it's somewhat comparatively less. But even then, all the contents are beyond the limits. They are excessing the quantities when compared to the reference limits, safe limits supposed to be. Finally, the indications of the study, which we can come to conclude, is because this industry polluted and domestic polluted water of Musi River, we are raising the crops in some of the locations along with the banks of the Musi River. So mainly vegetables are raised during the summer in these locations by marginal and migratory farmers using this type of polluted water. So paddy is also raised during the monsoon in adjacent districts of the Nalgonda. So the concern is the transmittance of the heavy metals is occurring into the animals upon being fed with fodder or grass or paddy straw grown on contaminated soils in the selected batches. So what are the actions? Some of the actions taken by the university with respect to this heavy metal study. So extension study was carried out by the Erstwhile Engineering Agriculture University, now it is bifurcated into Professor Jaishankar Telangana State Agriculture University in the Telangana. So our study was carried out to demarcate the hot spots in that polluted area. So research programs were related to assess the extent of the metal accumulation in soil, availability pattern and decontamination. Remediation methods also were initiated and were taken up during that period. So this extent of entry of these toxic metals in food chain through the affected food products just like milk, leafy vegetables and paddy crop has been assessed. So assessment of this assessment, how this assessment was done, it is to the extent of damage to the milch animals was studied, and its progeny has been taken up by the with the help of the veterinary specialist. So again, the other survey, that is exclusive survey of the groundwater within these watersheds, was also conducted. So we have developed some technologies to diversify these areas into non-food crops instead of these vegetable crops and crops which are harmful to the milch animals and human beings. So we have suggested we have to raise the non-food crops in these areas with this polluted water. So the collaborative studies have also been taken up along with the State Pollution Control Board to find out the actual sources of the pollution. So what are the sources of the pollution? Which are the pollutants letting into the Musi River? So we have taken the help of the Pollution Control Board to identify that such type of areas. So it included periodic surveys at the outlet of the industries, conference points at the river, and the entry into the farmers' fields, including water and air samples. So it is suggested to appoint exclusive staff to interact with the farming community along the riverbed to discourage the use of this polluted water and promoting the use of non-food crops like just like trees or timber and pulp, the different types of agroforestry crops in the area adjacent to the river banks through field and method demonstrations. And we have tried to establish the actual link of the produce from the river banks to the market, that is local markets where it is being sold, different types of right bazaars. So we have also created awareness regarding this pollution because we have tried to create the awareness among the farmers through the press, and we have also published different popular articles, news items, popular magazines, Telugu magazines, which farmers will read frequently, and we have also demonstrated through the different TV talks by the scientists in the different TV channels to create the awareness among the farmers, and we have given suggestions to the pollution control board to see the main concern is actually the all the industries which are letting out the effluent water. They have to before getting the license they will give undertaking that they will establish the treatment plant, and all treatment will be well treated with the treatment plants before letting into the normal rivers. But there is the main concern. Many of the industries they are establishing the industry. I mean, these treatment plants, but because of the huge expenditure they have to incur, they are not using the treatment plants to treat the pollutant, I mean industrial effluent water. Simply they are letting into the Musi River without treating the using the treatment plants. That is the main concern. The Pollution Control Board has to take care of this. They have to take stringent measures. So first point itself we take care so we can avoid the pollution of the Musi River water. We have advised the Pollution Control Board to strictly monitor and execute the proper treatment plants before letting out. And we are discouraging the requirements to farmers not to take up the different edible crops and replacing with the different types of fiber and agroforestry crops. So we have also different. This is the first of study our university has taken up for the Musi River pollutions. This initiation was the first of its kind during the 19 to I mean the 19 2009 different during 1998 only we have initiated. So we have published very good articles in the reputed journals. You see this one is the heavy metal contaminants in water, soil, plant, animal continuum due to the pollution of Musi River around Hyderabad city in India. This was published by me. I was the main scientist associated with this study. with the help of other scientists, co-scientists just like Patnaik and Sunendra Bama and other veterinary scientists, Kamalakar. So we have published this article in the very good reputed journal that is published by the Indian Council of Agriculture Research, New Delhi, that is Indian Journal of Animal Science. During 2006 we have published, and again we have also presented different papers in abroad also. During 2011 we have presented a paper that is transmittance of the trace metals into the animal system through soil water plant continuum under peri-urban environmental in Hyderabad city of India. So this was presented by then our director of research, Dr. P. Raghav Reddy Garu. So he has attended this conference, ninth international conference of the biogeochemistry on trace elements. It was conducted in the Beijing, the capital city of the China. So we, with both names, my name and Raghav Reddy, we have published this article. Another important articles, I have attended the second international conference on agricultural and environmental engineering in the Phuket, that is in the country of Thailand, during 2014. So I have presented this article, heavy metal contamination in soil, water, fodder, paddy, and some popular vegetables due to the polluted Musi river irrigation water around the Hyderabad city in Telangana state in India. So these are the very important articles we have published out of this. So we tried to create more awareness among the farmers to take up the non-edible crops, and we have advised the State Pollution Control Board to monitor the strict measures to monitoring the industries to treat the industrial effluent water, to use the treatmental plants effectively, so that the safe water will be released into the Musi river. So first point itself, we can take precaution for not polluting the Musi river with the heavy metal contaminants. So thank you very much for being patiently listened. Thank you.